machine learning is a perfect technology for this use case, right? I mean, you think about how many data can be produced by machines and by cloud, right? So that's massive amount of data. And so we are very good at actually watching videos. Like, we can recognize faces, we can listen, we can actually recognize speech very well. But we cannot actually find out the problematic machine among like millions of machines. No way you can do that. We are very bad at the time series analysis. So that's why I think the AI technology will play a very critical role.
Welcome to 20-Minute Leaders. Just sit back, relax, and learn from the leaders of today. It's a journey. Each one is different, unique, inspiring. Let's get started. 20-Minute Leaders is a proud supporter of Make-A-Wish Israel and Tech to Peace, and is in proud collaboration with Secret Chord Ventures, J Ventures, Riverside FM, Fusion VC, Birthright Excel, J Impact, Leap, Google for Startups, and Hippo, and in media partnership with CTech. Hello, and welcome to 20-Minute Leaders. Today, I'm with Dr. Helen Gu, Ph.D., who has made it her life's work to create unsupervised machine learning to detect anomalies in data in valuable ways. Based on more than 15 years of Helen's academic research and findings, she created InsightFinder, a tool that can help predict and prevent IT incidents based on algorithms that can determine an anomaly score and predict the future impact on a company's infrastructure. The platform also diagnoses the root cause of each system issue and provides automated self-healing capabilities to minimize the impact of service outages. In addition to being the founder and CEO of InsightFinder, she is also a computer science professor at the University of North Carolina and worked at IBM T.J. Watson Research Center, where she worked on the IBM stream processing system called System S. It later became IBM's InfoSphere stream product. Helen Gu, welcome to 20-Minute Leaders. Thank you so much for being with me today. How are you?
Good. Thanks a lot for inviting me here.
Thank you very much for being with me all the way from North Carolina, correct?
Yes, North Carolina and New York.
Oh, wonderful. Helen, you wear quite a few hats. Computer science professor at North Carolina State University, while also the founder and CEO of InsightFinder. Obviously, computer science is a big part of your life. Today, focusing at least in InsightFinder and with a few others and few other positions on unsupervised machine learning. And I'm looking forward to uncovering a little bit about your journey. And I'd love to start all the way the third grade when you started to learn how to program. How does a third grader get to start learning how to program? And this is not to today's third graders where we have all these cool coding games for kids. This is a different time where it wasn't as trivial. So I'd love to hear your story on that.
Yeah, that's almost like 40 years ago, 30, 40 years ago, right? So it is a year like, I think we are still using the first generation of Apple and IBM. So it was actually an interesting experience. I was in the elementary school and they were testing how to teach kids with programming. And so our school was selected. So I was actually get curious about the programming. And so I joined the program and start to actually learning. And since I'm falling in love with, programming and computer. So that's how I get started.
What was that? What was that like for a third grader to be involved with this experience of learning? And it also sounds like it wasn't necessarily a fully fledged out, curriculum that was, you were mentioning there you're sort of a part of this experiment, which obviously succeeded given where you're at today. But what was that experience really like for you?
Yeah, so they only pick a few kids to participate, and so I think it was actually most after school class, and so we are learning like programming using drawing some pictures. It's very similar to Scratch, but with some scripting languages, and so we learning basic and we even have like a competition, and you can So the one program I remember very clearly is that I made a kind of a keyboard, and you can play songs using computer keyboard, right? Simulating a piano keyboard. So that was actually the fun experience I remembered. Yeah.
So walk me through a little bit about your trajectory from learning how to program. You were part of IBM Watson research team, and you were also visiting scientists within Google. Walk me through a little bit about your career trajectory leading to this intersection of academia and entrepreneurship.
Yeah, so I started my PhD at the University of Illinois, and my PhD is about the distributed systems. I always fascinated about distributed systems because I believe, one machine won't do all the work, right? So that's all the starting point of, today's internet and, today's cloud computing, right? So it's all because distributed systems. And then when I started distributed systems, I started to actually realize how hard to programming a distributed program. And so it's a lot more challenging to make the program running smoothly on a set of machines than, compared to just running on one machine. So reliability, scalability, and those has been my passion. So I want to actually make the system reliable. And so that's my PhD work. So my PhD work is about using, kind of algorithms, not necessarily machine learning. And at the time, it's interestingly, I started to use neural network when doing my first PhD research. It was using neural network to predicting user preference. And so where they actually viewing the videos. So we were doing that video, mobile video on demand. So you can actually view the videos. At that time, there's no iPhones, right? So we had like a Palm Pilot, like the early days of compact computer. And so you can actually view the videos, and we in order to actually reduce the delay. So we predict what video user will watch, and we prefetch the video. So I was using neural network to predicting that. And so that's my first PhD research paper. And so later on, so I after I graduated and I joined IBM T.J. Watson as a researcher. And back then, we started actually a very interesting project. It's building the first kind of commercial grade distributed stream processing system. So real-time massive data analysis. That's way before Hadoop or Spark, any of those, later on system got invented. So I was actually responsible for maintaining, again, how to make a scalable and a really reliable distributed real-time data processing, stream processing platform. And so I work with a group of researchers, and they are basically using this platform to do analysis, like image analysis, video analysis, text analysis. So they are machine learning expert, but they are analyzing basically not the data produced by machine, but data produced by human, right? So I started to actually get interested in those machine learning algorithms, and so I'm saying, okay, you can use those algorithms to recognize patterns in video. Can we use the algorithms to recognize patterns in our machines so we can actually predict, okay, whether this machine is healthy or not, and whether this machine will actually, go down in the near future. So that's how I get started using machine learning to actually detecting system problems, predicting system problems. And so we were using supervised machine learning. And so we get some initial very interesting results. We can predict, like, for example, disk failures pretty accurately using those algorithms. And so then I left the IBM research because I want to really pursue this direction. So that's about 15 years ago. And so I joined NC State as a faculty because, I want to actually really focus on this. And I also realized it is really hard to actually apply supervised machine learning for machine data because you need to actually, high quality label the training data. And so it's very hard to actually label those machine data. And it's very massive. Second, is very fluctuating. So we start to actually, my students and I start to actually focus on using unsupervised machine learning. And so that's how we actually start our, research ideas in basically unsupervised behavioral learning. And that's, we start to actually be able to predicting problems without label training data. and we publish papers. And so that's basically when Google actually, a set of companies, they actually read the papers and they reach out to us saying, okay, this is an interesting paper. Can we use it in commercial world? So I started to collaborate with Google, and so that's how I end up being a visiting scientist at Google, testing our algorithms within the Google environments. And we eventually show that using our algorithms, we can do much more accurate and scalable anomaly detection at a Google scale. So we actually show that it has much higher accuracy and much better scalability than other algorithms. So Google actually licensed the technology, and after that, I launched InsightFinder. So we have been actually developing many new technologies and building the product as well. Yeah.
Wow. And so take me back to the original notion where you became fascinated or passionate about, scalability, reliability, detection, prevention from system failures. What was there? Was there an incident that led you to think this way? Was there something that led you to be so excited about this? What happened there?
Yeah. So first of all, myself is a programmer, right? I read a lot of code when I was doing Ph.D. and also working at IBM. I suffer, myself a lot from debugging distributed systems, and my husband is also a software engineer, and then he got woken up by his manager during mid of night because the production issues in his company, right? And so myself and we just like feel we use this technology all the time, right? So back then, so I always feel like the technology most important thing is connecting people. I think that's the most kind of powerful thing technology did to the human society. And so one of the examples I was actually using myself is that when my son is young, he's a baby, I was using the Next camera to monitor him, right? So I need to work, and so I cannot be at home. So I use the camera to monitor. And one day the camera went down, the service is gone, and I don't know whether it's something happened in my home or it's because the service is outage, right? So that's basically just means that sometimes if you use technology to do like patient monitoring, and that's sometimes it's life threatening if you have outages, right? So that's why I'm always like passionate about this, because any minute you save, any minute you reduce from the downtime, sometimes it means you save lives. So that's, I think it's extremely important. Rather than we just wait here for outage happens, and then we have to suffer from unknown consequence. And so let's be proactive. Let's actually harvest all the data we can analyze. And the machine learning is a perfect technology for this use case, right? I mean, you think about how many data can be produced by machines and by cloud, right? So that's massive amount of data. And so we are very good at actually watching videos. Like, we can recognize faces, we can listen, we can actually recognize speech very well. But we cannot actually find out the problematic machine among like millions of machines. No way you can do that. We are very bad at the time series analysis. So that's why I think the AI technology will play a very critical role. Yeah.
So no doubt about that, and I'm personally also excited about the technology and where we're headed and the different things that it allows us to do. What's a little bit about the strategy of the InsightFinder? How does the product work? And, if you can share with me some of the key insights that you've had into integrating sort of these solutions into the real world, as companies are. Obviously you're tackling a problem that companies have, and how do you, what is sort of the narrative that you found most appealing to different organizations, and what's been the right strategy here?
Yeah, I think we are trying to help our customers to change from reactive monitoring to basically proactive, prevention, right? So that's a fundamental paradigm change for a lot of customers. And so nowadays, basically, like I said, the downtime, the outage means a lot of, things for the company, right? Financial penalty, brand damages, and, sometimes it's, life-threatening, right? So all those things are extremely critical. And so if, I think that the company want to find a solution that can help them prevent from them. And so this is not a new problem. It's a long-lasting problem. And the problem becomes kind of more and more serious because we are, moving into cloud. We are relying on cloud. And a lot of times in the past, right? So you are using old days, like you are using IBM mainframe. You just have one or two machines, right? So you can hire people just sitting there and watch, babysit that. But now you have, I don't know, like, tens of millions of machines all over the world. And how do you actually use a human to watch all of that and to, when something bad happens and you have to actually manually diagnose, and this is not going to last, I think. So it is, it's a must-have kind of like, capability. A lot of, companies realize, right? They have to have these capabilities. Now, we're seeing a lot of like tools are developed in this space to help people to collecting data, monitoring data. But we see is that there's lacking basically a good analysis tool that can help the customer to figure out the insights out of those massive data. And like I mentioned, like human is not good at actually analyzing machine data. We are very good at actually giving limited information. We make decisions. And so the problem is that it's more like finding a needle in a haystack, right? So you have so many data, and how do you narrow down and to figure out, okay, how do I make a decision now? Should I actually restart my machine? Should I migrate my application? Should I add one more machine? Should I actually configure, upgrade my my database? All those decisions right now is made based on human experience. And it's empirical, right? And so a lot of knowledges are gone when people actually move their jobs. So now basically we're using AI technology to extracting all those insights out of the massive data and make it persistent, so you can actually leverage that you can reuse that. Yeah.
Really, really interesting. And do organizations understand this as you're, talking about with them? What's been their receptivity or the market education like for you?
Yeah, I think our message resonates very well with our customers, and it's not just like big customers, and we start from like most of Fortune 50 companies, but then we also talk to startup companies, right? So one of our customers is an online education startup company, and they serve over like millions of students all over the world. And so they don't have resources to actually babysit and watch their services all the time. So they rely on InsightFinder to actually find any like security bugs, the security breaches, and like code bugs in their system. They can actually be assured that anything happening in their infrastructure or application, InsightFinder will alert them, and they typically can know the root cause and fix the problem before their customers see it. So this message actually resonates well with customers, of all sizes. So the question is that, of course, the challenge is that, how to actually get the data and how to into the engine, how to provide surface bubble up the insights to our customers. So this is a very challenging problem. Not only it's a challenging science problem, but also it's engineering problem. It's basically also a usability problem because this is a new product. It's essentially you are saying that you want to give a crystal ball to our DevOps team to be able to prevent outages or fix problems downtime quickly. So this is a completely new thing to our customers, and most of the time we need to actually guide them through this journey. Yeah.
Interesting. How do you create differentiation in the space? What is it? Because maybe it's just a bias that I have that, I get to participate in the space a little bit, so that I know some interesting companies here. How do you differentiate to customers yourself from different companies who might be looking at tangential spaces?
Yeah, absolutely. So I think there's a lot of monitoring tools and help customer to actually provide a certain views to their systems. But we see the gap is that, everybody's trying to build ecosystem surrounding their tools. And from the customer perspective, if they want to do accurate root cause analysis and incident prediction, they need a data neutral tool. And this tool can actually plug into any data you have, right? Whether it's from a certain vendor or from the open source software. And so that's basically the day one kind of our mission and our positioning, right? So we are not locked down to any vendors or tools. We trying to be data agnostic and application agnostic, so we can actually allow the customer to plug in this engine to any existing monitoring tools they have, or kind of observability platform they have. And what we do here is basically extracting insights, right? And so that's what we want to laser focus on. We are not a monitoring tool company. We are not actually APM company.
Yeah.
We are not observability company. What we're trying to do is that we can turn all the existing tools you have into more intelligent insight. Yeah.
Got it. Sounds really, really cool. And I love how it sounds like over just the years you've become, this is a subject that obviously you've become really excited about. And I still can't believe you started coding so young. And it's such it's a really awesome journey. And I love the intersection of academia and entrepreneurship and obviously leveraging really interesting technologies to make a positive impact in the similar way that you're doing with InsightFinder. I think that's pretty inspiring. And so I really want to thank you for taking this time to spend here with me. 20 minutes is way too short to cover everything, but it was still really great hearing your story and what you're doing with InsightFinder as well as an estate. So thank you very, very much, Helen. I really appreciate your time. Best of luck and continued success with InsightFinder. And I can't wait to share this with others. Thank you.
Thank you, Michael. Yeah.